Okay, continuing with our resistive attenuators. Sorry for the nuisance phone call there. So we have to use RMS power, root mean square. It's the square root of the average square of the voltage. Voltage squared gives you power, and then you know when you average it over an entire cycle of a sine wave in our case, and then so you average it over that entire cycle. That gives you the average power. But again, to get back to volts, you got to take the square root. So square root of the mean square. And just to repeat what we said on that other sheet of paper, VRMS, and this is true also of current, but VRMS equals V peak divided by the square root of 2. And if it were current, IRMS equals I peak divided by the square root of 2. So when we take our half a volt peak and we divide it by the square root of 2, we get 0.3535 volts RMS. We square that, we divide it by 50 ohms, and we get 2.5 milliwatts, or 2.5 times 10 to the minus 3 watts. This is the case without the LPAD. This is if the 1 volt peak to peak, half volt peak, 0.3535 volts RMS were directly across the load resistor. With the LPAD in there, we found that it was half that. So it was half a volt peak to peak, 0.25 volts peak, or 0.17676 volts RMS. We square the RMS voltage, divide by 50 ohms, and depending how you like to write it, we either get 0.625 milliwatts. That's a fourth of 2.5 milliwatts. Or, more proper engineering notation would be 625 microwatts. In either case, the two resistors that we brought into this thing right here wound up burning 3/4 of our power and turning it into heat. And the last quarter of power made it to the load resistor to do whatever it does there. And again, you might do this because you want to reduce the amount of power impinging on the load because it represents a sensitive instrument, or maybe its range, it may be of such a design that it can only handle a very small signal. That's sometimes the case. So anyway, that's our first LPAD, and a little bit more about our first LPAD. There we go, sorry about that. Here's our first LPAD right here. If we look at this thing, we know that the resistance looking toward the load, we've got our 50 in parallel with our 50, gives us 25, in series with 25 gives us 50. So we plug this thing in, the source doesn't know that anything's there. It just says I'm driving 50 ohms like I like to and like I'm designed to. So he sees 50 ohms, but 3/4 of the power goes into this LPAD attenuator and only 1/4 of power to the load. So once again, we see 50 ohms looking from the source. If we look back from the load, however, we know from Thevenin and Norton that we're just going to short this thing out because it's a voltage source. So I got 25 in series with the internal resistance of the source. That's 75. So 75 in parallel with the 50 ohm load, or I'm sorry, the 50 ohm in the LPAD gives me 30 ohms. So I don't see 50 looking back this way, and that's not really a problem often. Okay, there are times when we'd like it to be 50 in both directions, and we'll pick that up in our next example. All right. See you then.